Welcome to the DIY Honda Garage channel. DTC P0116 indicates a problem with the Engine Coolant Temperature ECT Sensor 1 circuit, specifically regarding its range or performance. This diagnostic trouble code typically suggests that the readings from the ECT sensor are outside of the expected limits, which can affect engine performance, fuel efficiency, and emissions. In the Honda HRV from 2016 to 2022, the ECT sensor plays a vital role in engine management. It measures the temperature of the engine coolant and provides important data to the Powertrain Control Module, PCM. The PCM adjusts fuel injection and ignition timing based on this information to optimize engine performance and efficiency. The ECT Sensor 1 is usually located near the thermostat housing or engine block, often found in the engine bay. Accurate diagnosis and repair of this fault are crucial to ensure the vehicle operates properly. The ECT Sensor 1 is primarily responsible for measuring the temperature of the engine coolant. This measurement is crucial as it helps the vehicle's Powertrain Control Module, PCM, make informed decisions about fuel mixture and ignition timing, ensuring efficient engine operation. In the Honda HRV, this sensor is typically situated near the thermostat, allowing it to accurately gauge the coolant temperature. Proper functioning of the ECT sensor is essential for the overall performance of the vehicle. If this sensor malfunctions, it can lead to incorrect data being sent to the PCM, resulting in possible engine overheating or underperformance. Diagnosing issues with the ECT sensor involves checking the readings it provides and comparing them to the expected values outlined in diagnostic guidelines. The most common causes of DTC P0116 include a faulty engine coolant temperature, ECT sensor, wiring issues related to the sensor, and potential problems with the Powertrain Control Module, PCM. A faulty ECT sensor will provide inaccurate readings, leading to erratic engine behavior. Wiring issues can manifest as frayed or corroded connections that interrupt the signal sent from the ECT sensor to the PCM. These wiring problems can also involve loose terminals, which can create an intermittent fault. In some cases, if all else checks out, the PCM itself may be at fault for misinterpreting or failing to process the data given by the ECT sensor correctly. A careful inspection of all related components is crucial to correctly identify the fault. When DTC P0116 is triggered, several symptoms may present themselves, ultimately impacting the vehicle's operation. One of the primary signs is poor engine performance, which can manifest as sluggish acceleration or stalling. Additionally, drivers may notice increased fuel consumption due to incorrect air-fuel mixture adjustments that result from erroneous data. Another symptom is overheating, which can occur if the PCM isn't receiving accurate temperature readings, leading to inadequate cooling system management. Another symptom could involve the radiator fan operating inconsistently, either running too often or not at all when needed. Monitoring these symptoms can guide the technician in diagnosing the underlying issue with the ECT sensor circuit. The first troubleshooting step for DTC P0116 is to turn the vehicle to the on mode without starting the engine. This allows access to the Honda Diagnostic System, HDS, which is essential for reading various parameters and getting real-time data from the vehicle's systems. Once in on mode, the technician needs to check the ECT Sensor 1 values displayed on the HDS. This includes verifying whether the current values exceed the specified thresholds of more than 176 degrees Fahrenheit, 80 degrees Celsius. If the readings match or exceed these criteria, you note the value and proceed to the next step. If the readings don't meet these thresholds, then you must move on to the second troubleshooting step. The ability to interpret these readings correctly lays the groundwork for all subsequent diagnostics, ensuring precise and effective repairs. The second troubleshooting step involves verifying whether the ECT sensor issues are present at low temperatures. First, you need to note the ECT sensor 1 reading from the Honda Diagnostic System, HDS, at this state. With this initial reading in mind, start the engine and maintain an engine speed of 3,000 RPM without load, using park or neutral. This should be done until you observe the radiator fan activate, signifying a rise in coolant temperature. After that, you will again check the ECT sensor 1 reading on the HDS. This step is critical in determining whether the sensor is functioning intermittently or if a fault is indeed present. If you observe a change of 18 degrees Fahrenheit, 10 degrees Celsius or more in the ECT sensor 1 readings, it suggests an intermittent failure, advising further investigation for loose connections or terminals, but not automatically necessitating a part replacement. Alternatively, if the readings do not show this change, it indicates a definite fault that may require replacing the ECT sensor. The third troubleshooting step involves verifying the ECT sensor parameters under high temperature conditions. This typically requires the technician to turn the vehicle off and allow the engine to cool for approximately 3 hours. This cooling period is vital to reset the conditions so that any errors can be accurately assessed. Once the engine has cooled, you turn the vehicle to the on mode again. Now, again check the ECT sensor 1 readings via the Honda Diagnostic System, HDS. Just like in the previous steps, if the ECT sensor readings show a change of 18 degrees Fahrenheit, 10 degrees Celsius or more, it indicates that the sensor might still be functioning intermittently. Immediate action would involve inspecting the connections and terminals at both the ECT sensor and the PCM for any signs of corrosion or loosening. If readings do not show this requisite change, it confirms a failure and likely necessitates the replacement of the ECT sensor itself. After completing the repair, performing a final verification is crucial to confirm that the DTC P0116 issue has been successfully resolved. First, monitor if any of the initial symptoms, such as poor engine performance or increased fuel consumption, reappear. This monitoring should be carried out under similar conditions that previously triggered the DTC. Secondly, document and confirm that all repairs were effective without any recurrences of the error code. Running final diagnostic tests using the HDS provides an additional layer of verification, ensuring that there are no outstanding trouble codes related to the ECT sensor or its components. This is an essential part of the troubleshooting process, as it can save future time, effort, and costs if issues are properly resolved now. Preventive maintenance is vital in avoiding issues like DTC P0116 in the future. Regularly inspecting the engine coolant temperature, ECT sensor, can catch potential problems early, ensuring it operates effectively within its set parameters. Alongside sensor checks, perform routine inspections of related wiring and connections. This will help identify any frayed wires, loose terminals, or other deficiencies that could interfere with sensor performance. Keeping these connections clean is essential to ensure reliable signal transmission and to avoid the issues associated with corrosion and dirt buildup. Additionally, monitoring engine coolant levels and temperatures during standard vehicle maintenance can provide early warning signs of problems. By implementing these preventive measures, you can prolong the lifespan of the components involved, ensuring a more reliable vehicle. In conclusion, understanding the function and role of the engine coolant temperature (ECT) sensor is essential for diagnosing DTC P0116. The troubleshooting process requires precise measurements and comparisons against expected thresholds to accurately identify the problem. Following the structured steps, starting from checking current readings on the Honda Diagnostic System, HDS, verifying under varying temperature conditions, and ensuring thorough checks of connections, all lead to proper resolution. By taking the time to perform thorough diagnostics, technicians can avoid misdiagnosis and unnecessary repairs, ultimately saving both time and resources. Regular preventive maintenance also reinforces reliability, ensuring the vehicle maintains peak performance and efficiently manages engine temperature over time. Please like and subscribe to the channel. See you next time.